Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Hidayat binti Awang. I'm from Bachelor of Horns Mechanical Engineering at Uitm Shah. Okay, for the final year project, the project title that I will done is Characterization of Oil Impregnated Materials. Okay, now we will go through for the first one. This is the table of content. Uh, I have five the content in my slide, which is project summary, introduction, literature review, methodology, and expected result. Then we will go to the project summary. First of all, project summary, we will study of tribology, which include three: friction, wear, and lubrication. I have made the research that the characterization of all impregnated materials by using technology to make related testing to check the tribology of it. And then we will go to the introduction. I will describe about the three. First of all, the tribology examines crucial issues that can be divided into three categories: friction, wear, and lubrication. And then the subject that will I uh, study is oil impregnated. This is between the foam materials impregnated with oil, such as automotive, insulation, and packaging application. And then the technology that I will do is pin on this testing, Alicona, and SEM testing. Pin on this testing is used to compare the characteristic of a particular form material to solid materials, which is we can identify the friction and wear. And then go to the literature review. First and foremost, all impregnated materials, due to their low weight, excellent thermal and acoustic insulation, and high energy absorption, foams are frequently employed in engineering. According to historical evidence, people have traditionally used vegetable oil as a medium to lessen friction and wear. Plus, the researchers classify synthetic lubricant in various forms, including PAO, polyester, and polyalkyl glycol (PAG). And then, the thin lubricating coating developed under the PAO lubrication on the worn surface will increase the wear resistance by shielding the sliding surface. For the other tribology is friction. The friction, also known as the friction that the force that prevents sliding, depending on the contact between sliding surface and operational factors including roughness, degree of work hardening, and surface cleanliness. Friction in mechanical system may rise or decrease. I will also use pin on this testing to find the coefficient of sliding friction and wear. Then the sample were tested for up to certain minute at room temperature with a linear velocity and vertical load is applied. For the other tribology is wear. Wear happens when two surfaces in relative motion meet one another generally. In a dry run, Saka 1983 noticed that material is lost as debris, which is referred to as where when two components slide past one another. The wear in a steady state spin is utilized to determine the wear rate when a load is applied. Thus, in this investigation, the researcher used the pin on a disc to calculate the apparent contact pressure. I also study about the lubrication. A lubrication is a substance that acts as a coating between two moving parts to reduce wear and friction. When two surfaces are coated with a lubricant, lubrication occurs. And then by adding a additive, the base fluid may create a new property or improve an existing one to increase the lubricant performance. I have list the problem statement. First, in this study, I have identified that it has a complicated issue of lubrication. And then the behavior of oil. So to achieve the study, we must achieve the objective first. First, to investigate the process of impregnating oil into foam materials, then to characterize the tribology behavior of the impregnated foam materials using pin-on-disc testing, and then to examine the morphological characteristic of impregnated material surface using Alicona and SEM or scanning electron microscope testing. Then for the scope and limitation of the project, a reservoir for oil is made using foam material, making it simple to add a lubrication film. Then pin-on-disc testing is used to compare the characteristic of a particular foam material to solid material. Lastly, Alicona testing was used to gain surface roughness and SEM to evaluate the surface characterization. For the fourth content, we will go to methodology. Pin-on-disc, in the beginning, the oil impregnated material are at room temperature, and then with the identical constant load weight and foam friction speed are used in friction testing. A pin will compress by 2 Newton of force within the duration of 5 minutes, and then the rotation speed was 500 revolutions minute. The radius was 4 mm and the distance was 12.6 meter. So for doing the Alicona and is an optical 3D measurement tool that will use called the infinite focus microscope. Alicona was used to quantify and analyze the surface roughness. Then when we use the microscope, it will capture the image, which is vertical resolution of 10 and a lateral resolution of 400. It can show the typical surface topography plus display variation of 2D and 3D surface roughness. Thus, it is possible to view how the edge radius affects the machine surface roughness in both 2D and 3D. Lastly, for the scanning electron microscopic analysis, the SEM means the thin electron focus on the sample with high energy. In addition, the SEM generate high resolution image. So to doing this testing, the sample are divided into specimen that are 0.5 cm thick, 1.0 cm wide, and 1.0 cm long. The sample surface will be conductible after coating. After that, the sample is placed in the SEM and its surface morphology is examined before being scanned for around 50 until 150 fold enlargement. Then for the expected result that we have done for the 3 testing, which is pin-on-disc testing, Alicona testing, and SEM analysis. I have expect that oil impregnated material will produce an optimum tribology performance and the lowest friction coefficient. As the friction reduce, wear also will reduce. Then Alicona testing shows the surface roughness that traditional 2D surface roughness is insufficient to capture the character of the surface, while 3D surface roughness can offer more accurate measurement in image.